Hello. Yan. So, good morning. So, ngayon mag-aaral naman ulit ako ng plastic hinge, chapter 1.5 na tayo. Okay, so recap ng what we've learned in this nonlinear modeling by Dr. Fawad Najam and his classmates from NUST. So, last discussion, chapter 1.1 to 1.4. So we've learned na meron dalawang account lang na kino-consider sa industry practice, which are the fiber modeling and hinge modeling. Okay? So doon tayo na last meeting na discuss natin the fiber modeling. Okay? So the fiber sections for the beams, for the columns, and for the walls, and their limitations. Okay, so for the fiber section for the beams is the bending about the vertical direction or bending about the horizontal axis. Okay, so no bending in the horizontal direction since nakakabit daw siya sa slab and medyo rigid yung deformation doon. Okay. So the fiber section for the beams are this one, okay? Okay. Yung note ko, the fiber section for the beams are this one. So take note that the fiber sections are parallel to the bending axis, okay? So for the columns naman, the fiber section for the columns are considering the bending in X and the bending in Y direction. Okay, so bending in X and Y direction. So ibig sabihin, yung fiber section will na gagawin natin is bending in Y and in X axis like this one. And also, kung mapapansin natin, there is some part lang ng fiber segment na kino-consider, hindi yung whole segment. Okay, so this one is for the column. And for the fiber section for the walls, same with the beam, isang side lang din yung kino-consider, the in-plane moment or in-plane moment. So the bending about this axis, okay? So this one, okay, these are the deformation. So bending about that axis, yun lang yung fiber section na kino-consider for the walls. Okay. Then we need to accurately divide the section into plane parts, okay? So kapag ganito yung section, i-divide natin siya into plane parts and the limitations, okay? So today, doon naman tayo for the plastic hinge modeling approach. Okay, so for the plastic hinge modeling approach, subdivided siya into two parts. Okay, so chapter 1.5, the plastic modeling, So for the plastic, this one, so for the plastic hinge modeling approach, subdivided siya into two parts. So plastic hinge modeling of the RC beam taken from Dr. Powell. So discussion for the nonlinear analysis. So nandun siya sa YouTube. And 1.5.2 is the force deformation relationship by the ASCE 421 and the performance-based evaluation. So okay, sige, let's start. Pag-aralan natin. Okay, so in chapter 1.5, so the plastic hinge modeling approach or the concentrated nonlinearity. So recall for the plastic hinge modeling approach is ganito siya. Okay, so we have three types, di ba? Meron tayong three assumptions. Three assumptions natin or the three approaches are column continuum model or the continuum model, distributed inelasticity or fiber model, and hinge model. Okay, so ngayon dito tayo sa hinge model. Okay, concentrated inelasticity hinge model. Okay, so doon tapos na tayo sa fiber modeling. So dito na tayo sa hinge modeling. Okay. So plastic hinge modeling approach. So the fiber modeling approach is based on the defining the nonlinear properties directly at the fundamental material level, which then manifests at the cross-section, so member and structural levels. Okay, so in the plastic hinge modeling approach, it is assumed that all inelastic deformation is concentrated at certain points or locations defined by the zero length hypothetical elements known as the plastic hinge. So for the plastic hinge modeling nga, the approach daw is the assumption that all inelastic deformation is concentrated only at the certain points or location defined by the zero length hypothetical element as the plastic hinge. So we will assuming na yung inelastic deformation is at the plastic hinges lang. Okay? So using these plastic hinge, so I think I should take note of this. Sabi niya dito, the plastic hinge modeling, sabi niya, the assumption or all inelastic deformation is concentrated in the plastic hinges. Okay. So since we all know the plastic hinges, okay, so using these plastic hinges, the inelastic relationship or relating to the particular structural action of the corresponding deformation, it is directly defined at cross-section or members level to include the effects of the nonlinearity in the overall structural stiffness. Okay, so instead of specifying the inelastic material properties, so in structural model daw, the location at which the inelastic action is assumed concentrated. So the locations of the plastic hinge. So example, the location of the plastic hinge, nandun daw lang yung concentrated, assumed concentrated inelastic action. So it is are based on the expected zones of damage under the anticipated loading. So for example, in the figure 1-13, okay, the figure 1-13 is this one. Okay, this one. So in the figure 1-13, the shows the bending moment of shear force diagram of a 2D frame under the gravity loads and under the lateral loads. So as we can see, these are the gravity loads and these are the lateral loads. So ito yung shear and moment diagram. Okay. So for a 2D frame. So therefore, the under lateral dynamic loading or the inelastic action or flexural yielding of the beams, it is expected to mostly concentrate in these regions of high bending moment. So therefore, the inelastic action can be captured in the modeling in the model by specifying the plastic hinges at both ends of these elements. So for the plastic hinge modeling, dun lang daw siya sa location at which daw expected the mostly high demands or bending moments. Okay, so take note of this. We need to take note of this. So therefore, under daw sa lateral dynamic loading, the inelastic action or the flexural yielding, take note of this, the flexural yielding of beams or in columns, okay, is at regions of high bending. So, okay, doon daw siya nakalagay. So the flexural yielding is at regions of high bending. Okay, so therefore the inelastic flexural action can be captured in the model by specifying the plastic hinges at both ends of these elements. So for example, this one. So in the figure 1-13 daw, so it is the shear and bending diagram of a 2D frame under the gravity loads and under the lateral loads. So these are a source from the AIET solutions. Okay, so basic lang. So basic free moment shear and diagram. Okay. So in figure 1-14, this one naman shows the lamp plasticity or the plastic hinge model. Plastic hinge. So model of our 2D RC frame in the left and subjected to lateral earthquake loading. So these yellow circles, both ends of the beams and base of the ground floors, the columns. So show the potential location of the inelastic actions due to this loading. So yung yellow line or yung yellow line is the potential locations of the plastic hinges. So yun daw yung point at which nandun yung high bending. Kung mapapansin natin, ito yung point kung saan yung high bending. So ito yung point, high bending, high bending, high yung bending dito. So parang dun siya talaga sa may mga ends, di ba? Sa mga ends. Okay. So the yellow figure, the yellow legend is potential location of plastic hinges. So in between hinges, the elastic frame element is used to capture the elastic response of the member. So then the nonlinearity is assumed to be concentrated only at the plastic hinges. Okay. So in this process, okay, based on my understanding, in this process, the location at which the plastic hinges or the inelastic deformation is only at the location or at the region where the high bending moments is expected to occur. Okay, so for example, for the beam and the column, dun siya sa may ends. Okay, so in between the hinges or in between that plastic hinges, the elastic frame na yon. So capturing yung dun sa in between, magka-capture siya ng elastic response. Okay, and dun sa may region kung saan naglagay tayo ng location o potential location of plastic hinges or the inelasticity, dun daw yung assumed to be the location at which we will focus the inelastic analysis. Okay, so dun tayo. So this one is the RC frame subjected to earthquakes, and this one is the lump plasticity model. Okay, so lump plasticity, ayan. Okay, so I see. So, mapapansin nga natin is nandun talaga sa may ends. Ayan, mga ends. So, for the column, syempre, ito lang yung column natin. This one's the only column. Dun lang sa may support, malapit. And for the beams, kinapansin ko is puro nandun sa ends. So, at the joint is nandito lang. Okay, so for the column, isa lang talaga. Okay, so this is one column. So 3-story column to, dito lang sa may ends sa ilalim. 3-story column dito lang sa ends. 3-story column is nandito lang sa ends. Okay, so similarly in the figure 1-15, so figure 1-15, this one, taken from the ATC 72. Okay, so pier to sa pier. So illustrates the key features of the inelastic plastic hinge model for reinforced concrete frame elements. So then the nonlinear relationship between the moment and the flexural deformation of the member is assigned to plastic hinges at both ends of the column, shown in figure 1-15A. Okay, dash 115A. So the features of these elements are generally applicable to other type of elements. So this example is taken from the study of reinforced concrete columns by Hasselton et al. In 2008, making use of degrading cyclic model developed by Ibarra and Krawinkel in 2005. So in this example, the inelastic response is idealized by a backbone curve in a figure 1-9b. Okay, what is a figure 1-9b? Okay, I think okay, I think this one should be figure 1-15b. I think this one is figure 1-15b. Okay, so that relates the moment to rotation in the concentrated hinge. So ito yung moment, ito yung rotation. So this one should be 15b. Okay, so the definition of the backbone curve and its associated parameters depends on the specific attributes of the nonlinear model used to simulate the hysteretic cyclic response. So into figure daw na to, ito daw yung illustration of the inelastic hinge model. Itong figure na to is ang tinatawag nila na initial backbone curve. Okay? And this region is the cyclic response model. In this figure is the cyclic response model. Okay. So, balikan natin. So the nonlinear relationship between the moment and the flexural deformation of a member is assigned to plastic hinge at both ends. So same. So the feature of this element are generally applicable to other type. So okay. So wala naman nabanggit. Okay, so wala naman nabanggit. Binanggit lang naman dito is the key features daw, yung inelastic plastic hinge are model in a reinforced concrete frame elements. So ito daw yung flexural deformation of members. So tinatawag siyang nonlinear relationship between the moment and the flexural deformation of member is assigned to plastic hinges at both ends. So ito, the nonlinear relationship between the moment and the flexural deformation of the member is assigned to plastic hinge at both ends. Okay, so ibig sabihin, yung moment and the flexural deformation is the plastic hinges, plastic moment at that ends. Okay. So, as you can see, tama. Kasi 'di ba in steel design, the MY the plastic moment is greater than my, di ba? So basically, tama. The location at which ito yung nag-produce ng moment at plastic, ito yung plastic moments. Okay, so in column C, ito yung backbone curve. And figure C, ito daw yung cyclic response model na nag-undergo dito sa this model. Okay, so ito yung model. Okay, sige, let's see. So in the above example, the plastic hinges defined at the both ends of the column are flexural hinges. Okay, so in this example, okay, take note of this. In this example, the plastic hinges are defined at the ends of the column and model as flexural hinges. So take note this one, flexural hinges at ends. Okay. So with a specified moment versus relationship versus rotation relationship in the primary flexural direction. Okay, so need daw natin mag-specify ng moment versus rotation relationship in the primary relationship, primary flexural deformation. Okay, kailangan daw natin mag-specify. Yun yung pagkakaintindi ko. Okay, so however, several types of plastic hinges can be used to specify the nonlinear force deformation relationship. So in general, the action deformation relationship. So for any degree of freedom at a particular location along the member. Okay, so daw, pagkakaintindi ko, there are several type of plastic hinges that can be assigned to the specific, to that is specify nonlinear force deformation relationship. Okay, so in any degree of freedom of at a particular location along the member. So ibig sabihin, since we're dealing it a different degree of freedom, so in shear, meron siyang shear hinges, I think. Kasi ibig sabihin niya dito meron daw degree of freedom at a particular location along the member. So the degree of freedom naman, di ba, we have 6 degree of freedom in each node, di ba? We have 6 degrees of freedom in each node. So corresponds to UX, UY, and UZ. And theta X, theta Y, theta Z. And U is the force, corresponds to force, force displacement relationship. And the theta corresponds to the moment at that nodes, okay, at that degree of freedom. So ibig sabihin, meron daw several type of plastic hinges that can be specified in that location. Okay, so take note of that. So yes, meron daw iba't ibang type of plastic hinges. Okay, so take note ko to. So meron daw tayong several type of plastic hinges. Okay, so the several types of plastic hinges elements are available in Etabs or perform 3D. Oh, tama nga. So it can be used in this for this purpose. So for example, the figure 1-10 below, figure 1-10 below, this is a figure 1-10. I think this should be 1-16. Okay. Okay, this should be 1-16. Okay, ayan nga, tinaman sinasabi ko. Below shows the 6 degree of freedom and corresponding actions for the node in the 3D space. So this includes the moments in 2 direction, the shear in 2 direction, and the axial force and torsion. So these are the 6 deformation corresponding to the 6 actions. So the relationship between each of the action and corresponding deformation is defined by the action deformation relationship. Okay. So the plastic hinge elements allow us to specify a nonlinear action deformation relationship for each of the action in the structural model. Okay, so very good. Tama. So this includes, for example, the nonlinear shear force versus the shear deformation relationship. Okay, so ito yung tatlo. Very good. So this one is the shear force versus the shear deformation relationship. We have the nonlinear axial force and the axial deformation relationship. Okay. So tama nga. So meron tayong iba't ibang plastic hinges types. kung meron tayong 6 degrees of freedom. So for example, this one, di ba sa natin sa each node of a 3D figure model o 3D space, meron tayong 6 degrees of freedom in each node. We have the UX, UI, UZ, RX, RY, RZ. Okay. So corresponds to the VZ, VX, and the actual load. Okay, UI is for the actual load. Okay, UX is for the shear and X. Okay, based on this axis VZ. Okay, the RZ is comes based on the moment in Z, moment in X, moment in Z is the bending in that direction, moment in. Okay, ibig sabihin ng arrow na yan is nandito. Okay, so kina-curl mo siya. So MY is the torsion. Okay, MX is the bending in horizontal direction, MZ is bending in the vertical direction, and MY is the torsion. Okay, so for the moment, flexural plastic hinges can be of the curvature type or a rotation type. Okay, so meron pang dun sa flexural, meron pang dalawa. Meron pa daw curvature type or rotation type. So the curvature type is plastic hinges are used to introduce the nonlinearity at the cross-sectional level. And the primary force deformation relation assigned to these hinges is the moment curvature relationship. Okay, so the deformation measured for the demand to capacity ratio is hinge curvature. So the rotation type plastic hinges as shown in the example figure 1-9 are used to introduce the nonlinearity directly at the member level. So the primary force deformation relationship assigned to these hinges is the moment rotation relationship. So the deformation measure for the demand to capacity ratio is the hinge rotation. Okay, so I think we should take note of that. Okay, take note natin dito. Okay, according to this segment, yung moment plastic hinges or the flexural plastic hinges, or tik dito na lang sa gilid. Yung flexural plastic hinges, okay, meron siyang dalawang part. Meron diyang can be a curvature type. Okay, and merong isang rotation type. Okay. So for the curvature type, okay. So for the curvature type, ang sabi niya, the curvature type plastic hinges are used to introduce the nonlinearity at the cross-sectional level. So ibig sabihin, this one, the curvature type are used to introduce the nonlinearity at the cross-sectional level. So the primary force deformation relationship assigned to these hinges are called the moment curvature relationship. So for under the curvature type, ang force deformation relationship, okay, are called the moment curvature relationship. Okay, so MC relationship. Okay, yan na lang ilalagay, ipapangalan ko. Okay, okay, ang ipapangalan ko na lang is moment curvature. Okay, in rotation type, meron pa tayong isa. Ang tawag dyan is moment rotation relationship. Okay, so the deformation measure for the demand capacity ratio is called hinge curvature. Okay, hinge or curvature yung tawag dito sa demand capacity ratio dito. Okay, so the demand capacity ratio and the demand capacity ratio for number 1 is called hinge curvature. Siguro hinge rotation yung isa. Okay, tama. So this one is the hinge rotation. Okay. So the deformation measure for the demand capacity ratio in the is hinge curvature, and the rotation type plastic hinges as shown in the example are used to introduce the nonlinearity directly to the member level. So the primary force deformation relationship assigned to these hinges is the moment rotation relationship. So yung rotation type. So sa rotation type, ginagamit ito for the nonlinearity directly at the member level. Okay, dun sa curvature type naman is used to introduce na nonlinearity at the cross-sectional level. Okay, so recall, yung cross-sectional level is the the I, okay, the I, and for the member level is for member length. Okay, let's see. Balikan natin. Okay, according to dun sa okay. Okay, wait. So for think dito pa yun sa taas. Ayan. So okay, I think nandito. Wait lang guys ha. Ayan, ayan. Cross-sectional level and member level. Hello, hello. Ayan, I see. Nakita ko na. Okay, so this one. Okay, this one. Yan. For material property, material level, they are dealing with E. For the cross-sectional level is AI. And for member level is the length. Okay, so meron tayong member level, cross-sectional level, and material level. So kung babalik tayo doon, okay, so babalik tayo dito sa the hinge modeling. Okay, so sabi niya, so okay, yan, this one. So the moment or the flexural hinges in the curvature type is based on the curvature type and rotation type. So yung curvature type is the plasing hinges used to introduce the nonlinearity at the cross-sectional level. So ibig sabihin, curvature type yung gagamitin natin if we introduce the nonlinearity at the cross-sectional level. Ibig sabihin yung area and the inertia. Okay. Ang gagamitin naman natin is moment rotation relationship if or the rotation type if we are the nonlinearity na i-introduce natin is at the member level. Ibig sabihin the length, member level is the length. Okay, we have the material, cross-section, and member level. So member level is the length. Ang tawag din is moment rotation relationship. And doon naman sa isa is the moment curvature relationship. Okay. So the curvature type, ibig sabihin, balik natin dito, are cross-sectional level. Okay. Cross-section. Okay. And for rotation type is for member level. Member level, ibig sabihin the length. And for the cross-sectional level, ibig sabihin area and inertia. Okay. Okay. So for the plastic hinges, the flexural hinges, shear hinges, axial hinges, and torsional hinges. So in flexural hinges can be two. Pwedeng moment curvature type of plastic hinges or moment rotation type plastic hinges. So for this one is the cross-sectional level. Or dealing with area and inertia. And for this one is dealing with the member level or the length. Yan. Okay. So yan. Yun na. Lahat. Meron tayong of 4 plastic hinges, the flexural, shear, axial, and torsion. And in flexural, merong dalawa, moment curvature and moment rotation type. So the following are some important features of this model. Okay, so for the backbone curve, so the backbone curve is generally expected to capture both hardening and post-peak softening response. So the peak point of the curvature, the peak point of the curve is sometimes referred as the capping point, and the associated deformation capacity is the capping deformation. Okay, so I think I shared this one. The peak point of the curve is referred as the capping point, and the associated deformation capacity is the capping deformation. Okay, so the extent to which the cyclic deterioration is modeled in the analysis will determine the extent to which the backbone curve is calibrated to initial or degraded component response. So when how the characteristic points on the curve corresponds to component acceptance criteria for the onset of damage and the significant deterioration. Okay, next one is the cyclic model. For the cyclic model, incorporates now the deterioration in strength and stiffness, which degrades the backbone curve as a function of the damage and energy dissipated in the component. Okay, so accordingly, the initial backbone curve given in a figure 1-9b. Okay, I don't think tama yung figure. So figure 1-15b. Okay, ito yung backbone curve eh. Sorry. So for figure 1-15, tama ba ako? 1-9? Tingnan nga natin yung 1-9. Talaga ito yung sabi niya. I think malayo na yung 1-9 eh. Hindi siya backbone curve eh. Tama nga. So 1-9. So i-check pa nga natin yung 1-9. 1-10. 1-9. So mali nga. Mali nga. Okay, mali. So 1-15 yung tinutukoy niya. Sige. So it should be 1-15b. Okay, so ito yon, ito yung tinutukoy niya. Ito yung backbone curve. Okay. So according to the book or the document we are understanding and we are reading is the cyclic model incorporates the deterioration in the strength and the stiffness at which that degrades the backbone curve as a function of the damage and energy dissipated in the components. So accordingly, the initial backbone curve given in a figure 1-15b, okay, this one is the figure 1-15b, okay, calibrated to component response that is representative of the monatomic loading. So when property calibrated, the cyclic deterioration enables the model to capture the deteriorated cyclic response of the components. So however, not all models can capture the strength and stiffness deterioration. Okay, where the cyclic deterioration is not accounted for in the model. So the backbone curve should be modified by appropriate reductions in the peak strength and the inelastic deformation quantities. Okay. Sige. So, base dito sa nalaman ko, sa cyclic model is this one. Okay. So, cyclic response model or based from the column drip and the shear force. So, according to the important features, yung cyclic model daw incorporates daw the deterioration and the strength and stiffness. So, ito yung deterioration or paghina ng strength and stiffness natin. Okay, so which degrades also the backbone curve in the function of the damage and energy dissipated in the component. Okay, so accordingly, the initial backbone curve is calibrated to component response that is representative of monatomic loading. So when the property calibrated, the cyclic deterioration enables the model to capture the deteriorated cyclic response of the component. Okay. Okay. Sabi niya, yung cyclic deterioration daw in the model enables to capture the deteriorated cyclic response of the component. Okay. So yung cyclic deterioration it will enable us to capture the deteriorated cyclic response of the component. So however, not all models can capture the strength and stiffness deterioration. So where the cyclic deterioration is not accounted for in the model, the backbone curve should be modified by appropriate reduction in the peak strength in elastic. Okay. So sabi niya dito, kapag hindi daw na-capture yung ito, the cyclic response of the model, so hindi na-capture yung cyclic response of the model, the backbone curve is modified at a certain factor or modified in a certain appropriate reductions in the peak strength to capture to replace the cyclic deterioration na hindi natin na-capture. Yan. Okay, take note. Okay, so should take note of that. Sabi niya kapag hindi daw if hindi daw nakuha, the cyclic deterioration is not accounted for in the model. So the backbone curve should be modified by appropriate reduction in the peak strength and inelastic deformation quantities. Okay. So next is the backbone curve and the cyclic deterioration properties should be calibrated to median response of the component. So take note of this one. Sabi niya, dapat daw makalibrate natin into median response of the components. Okay, yung backbone and cyclic deterioration. So this one, the backbone curve and the cyclic deformation. Okay, or the cyclic response. Okay. In this way, the basic modeling results will represent median or statistically neutral assessments of response. So variability in component properties or the system response can be applied to establish appropriate margin against exceeding certain limit states as evaluated through acceptance criteria on structural components and or the overall system. So take note of this. Okay, we need to represent a median or a statistically neutral assessment of the response. Okay, take note, we need to represent a median or a statistically neutral assessment of the response. Okay, so that's it for today. Okay, so I have plans, other plans pa. Okay, so discuss natin ang chapter 1.5 at which yung overview of the plastic hinge modeling approach. Okay, so I think I should recall what I've learned in this topic. So in the plastic hinge modeling approach, basically, ina-assume lang yung inelastic deformation is the region where the plastic hinges are located. Okay, so for example, the beams dun sa may ends, the column is dun sa isang ends or sa other ends. Okay, so also the location of the plastic hinges is where the region of high bending demands or high bending. So for example, in the 2D frame of lateral loads, okay, subjected to lateral loads, the high bending location is at these ends, okay, these ends or this joint. So ibig sabihin nandun yung plastic hinges location. Okay, so these are the example of lamp plasticity model and these are the deformation under the lamp plasticity model. Okay. So next is we have different plastic hinges. Okay, we have different plastic hinges to capture different types of force deformation relationship. Okay, so we have flexural hinges, shear hinges, axial hinges, and torsional hinges. Okay, under the flexural hinges, meron pang two. Okay, we have the moment curvature plastic hinges and the moment rotation plastic hinges. Okay. So before that, we have this example na meron tayong moment. This one is the backbone curve. The backbone curve tell us the relationship of the rela- uh, the the deformation of a member to the nonlinear moments and flexural, okay, deformation. So this one. And the column, the cyclic response is the response of the model, the column drift, or example, displacement over height over to compare to the shear force. Okay, so this one is the cyclic response of the model. Okay, so back to the types of plastic hinges, we have the flexural hinges, the two types of plastic hinges. We have the moment curvature plastic hinges and the moment rotation plastic hinges. So under the moment curvature plastic hinges, we have the cross-sectional level at which uh, we are introducing the nonlinearity at the cross-sectional level. Ibig sabihin, the nonlinearity part lang is at the area and the inertia for the cross-sectional level. And for the member level, which is stated as the moment rotation plastic hinges member level, ang nonlinearity na ini-introduce natin is at the length of the member. Okay? Directly at the member length. Okay? And the demand capacity ratio for moment curvature plastic hinges is tinatawag siya na hinge curvature, and for the DC ratio for this moment rotation plastic hinges are hinge rotation. Okay. So for the backbone curve, the peak point of the curve is sometimes referred as the capping point, and the deformation is sometimes referred as capping deformation. Okay. So for the cyclic model, according to that, hindi daw lahat, not all model can account for the cyclic deterioration. So we need to modify the backbone curve to appropriate reduction in the pure strength and an inelastic deformation to replace the missing cyclic deterioration or yung hindi natin na-account na cyclic deformation. Okay, and also dapat daw yung backbone curve and the cyclic deterioration should be properly calibrated at the median response of the component. So dapat daw basically mathematically represent statistically neutral yung assessment natin for the response. So maybe we can use median or the average or any statistically neutral na pag-assess. Okay, so yun lang lahat na naiintindihan ko. Okay, sige. Thank you for listening in my study time. Okay, so goodbye and see you for 1.5.1 and 1.5.2. Okay, bye-bye.